Hi, this is Aditya. Welcome to my channel Sigma Modulo. In this video, we are going to discuss about an amazing math video problem. That is one of a famous math problem in the 18th century. That is Basel problem. Basel problem has its relevance to the number theory, and this problem was first posted by an Italian mathematician Pietro Mengoli in 1644. In 1650, Mengoli included the problem in a book on the summation of series. The problem is what is the sum of the reciprocal of the square of the positive integer, that is this one, summation of n is equal to 1 to infinity 1 by n square is equal to 1 by 1 square plus 2 by 2 square plus 1 by 3 square plus 1 by 4 square up to infinity. What is the value of this exact value? Mengoli wanted to know about the exact value of this series. The problem became well known when Jacob Bernoulli wrote about it in 1689. Jacob was the brother of Euler's teacher, Leonhard Euler teacher and mentor of Johann Bernoulli, who probably saw the problem. It seemed that Euler did not come to Basel problem directly. Indeed, his attack on the problem began with one of those forgotten problems in the early 18th century. Eventually, Leonhard Euler solved the problem in 1734. It's not 1734. Euler's solution brought him immediate fame when he was 28. Euler generalized the problem considerably, and his ideas were taken up years later by Bernhard Riemann in his seminal paper in 1859 with the title On the Number of Prime Less Than a Given Magnitude, in which he defined zeta function, that is we know today, Riemann zeta function, Riemann hypothesis, and he provides its basic properties. And we will stick to the Basel problem here, and we'll discuss Riemann hypothesis, which is a Millennium Prize problem, later on. And our aim is to discuss about this Basel problem is that we needed to have a overview before discussing Riemann hypothesis, that is a unsolved problem. So Leonhard Euler solved Mengoli's problem in 1734, and the problem it named after his hometown Basel, that is in Switzerland. And Euler has given 4 distinct solutions to this problem put forward by Mengoli, and we will discuss here each of them part by part. And this is our first part, and we will discuss the first solution that is given by Leonhard Euler in this video. And Euler's first solution seldom discussed elsewhere, and we are able to discuss his first solution itself. Before discussing the first solution put forward by Euler, we need to draw a circle. Euler draw a circle. Euler draw a circle with an arc length of S, that's S, and AM, that is arc length, which is equal to S, and A is the smallest positive arc with the same sign S, and he take y is equal to PM, the y is equal to PM, that is y is equal to sin S, and the small p is the periphery of a circle of radius, that is pi. Okay, the S be the length of an arc, S be the length of an arc, length of an arc, length of an arc, AM, AM is equal to S, and AM is equal to A. A is the smallest, positive arc with the same sign, as S, and Y is equal to PM. We join PM and small p here. Small p here is the semi-periphery, of a circle of radius 1, of a circle of radius 1, that is to say pi, and Euler takes y is equal to sine S, and he wrote down the Taylor series. That is y is equal to S minus S cube by 1 into 2 into 3 into 3 plus S to the power 5 divided by 1 into 2 into 3 into 4 into 5 minus S to the power 7, 1 into 2 into 3 into 4 into 5 into 6 into 7. Now divide the series by y, and subtracting from 1, we get divide the series by y, and we subtract the series from 1, that is 1 minus y by y is equal to 1 minus S by y plus S cube divided by 1 into 2 into 3 into y minus S to the power 5 divided by 1 into 2 into 3 into 4 into 5 into y plus S to the power 7 divided by 1 into 2 into 3 into 4 into 5 into 6 into 7 to y minus. Now Euler factored this series as if it were a polynomial. Factoring the series, as polynomial, factoring the series as a polynomial, and we get 1 minus, this will be 0, this will be 0, y cancel. 1 minus s by y plus s cube divided by 1 into 2 into 3 into y minus s to the power 5 1 into 2 into 3 into 4 into 5 into y plus s to the power 7 divided by 1 into 2 into 3 into 4 into 5 into 6 into 7 y minus, this is equal, and he factored the series. It gives a factor of 1 minus s by a, 1 minus s by b, 1 minus s by c, 1 minus s by d. It goes like this. Matching the term. Now what he did, matching the term, containing s to the first power, you get 1 by y is equal to 1 by a plus 1 by b plus 1 by c plus 1 by d up to infinity. And he does the same thing with s square, for which he gets 0 on the left, and he does the same with s cube and s to the power 5. He does the same thing. Now by periodicity of sine function, periodicity of sine function, the other arc will be with the same sign as s are a comma pi minus a twice pi plus a thrice pi minus a 4 pi plus a. The other arcs are five pi minus a, 6 pi plus a, etc. and minus pi minus a, minus twice pi plus a, minus thrice pi minus a, minus 4 pi plus a, minus 5 pi minus a, etc. And these arcs will give the value of a, b, c in the series and his infinite product. And he say 1 by y is equal to 1 by a plus 1 by pi minus a, 1 by minus pi minus a plus 1 by twice pi plus a plus 1 by minus 12 pi plus a plus 1 by thrice pi minus a minus thrice pi plus a matching the coefficient. Now he matches the coefficient, and the sum of the product taken two at a time gives him result of 0, and taken 3 term at a time it gives a result of minus 1 divided by 1.2, 1 into 2 into 3y, and so forth. Right on. Matching the coefficient. Matching the coefficient. Matching the coefficient. The sum of the product taken two at a time gives the result of 0, and sum of the product taken 3 at a time gives the result of minus 1 by 1 into 2 into 3 into y, and this goes like this. He uses some factors. Here he uses some factors about series which are seldom used today. If he says if alpha is equal to a plus b plus c plus d plus e plus f, etc., and beta, which is a sum of these terms taken two at a time without repetition, beta ab plus ac plus bc plus ae plus bd plus af plus be plus cd, etc., that is sum of this term taken two at a time without repetition then a square, he gets a square plus b square plus c square plus d square plus e square is equal to alpha square minus twice beta. And he denotes some Greek letter and the English alphabets. Alpha, he denotes alpha, beta, gamma, delta. These are the sum of the terms taken 1, 2, 3, 4 at a time respectively, and P, Q, R as denotes the sum of the terms taken to the first, second, third, fourth power respectively. By doing this, he gets By doing this, he gets P is equal to alpha, so one condition, Q is equal to P alpha minus twice beta, that is second condition, R is equal to Q alpha minus P alpha plus thrice gamma, this is the third condition, S is equal to alpha minus Q beta plus minus 4 delta, that is the fourth condition. This is the fourth condition. First, second, third, and fourth. What is P? The sum of terms taken first power. Then Q is the sum of terms taken second power. R is the sum of the terms taken third power. Sum of the terms taken third power. And S is the sum of the terms taken the fourth power. Okay, alpha beta gamma is the sum of terms taken 1 2 3 4 at a time. Okay, in Euler series, Euler series alpha is equal to Euler series alpha is equal to 1 by y, beta is equal to sum of terms taken taken 2 at a time, that is beta is equal to 0, gamma, that is sum of terms taken 3 at a time, we get the result 1 2 into 3 into y, that is we get this one, matching the coefficient, we get the sum of this one is 0, we put the value there, and delta is equal to 0, and so on. So from the condition, so now putting this value in these conditions, that is P is equal to 1 by y, we get here P is equal to 1 by y, that is 1 by y, and beta, that is in Q we put the value of beta here, that is 0, and like this. So from the conditions, P is equal to 1 by y from one condition here. From second condition, get rid of P by y, Q is equal to P by y, that is 1 by y square. Third condition, from third condition, R is equal to Q by y, R is equal to Q by y, that is 1 by twice y, Q by y, r is equal to, these are q alpha p beta, p is equal to 1, and q is equal to 1 by y square, r is equal to r is equal to thrice gamma. One by q by y minus twice y, and from third condition is implied s is equal to r by y minus p by 1 into 2 into 3 y. Up to now, Euler has been doing his development in some generality without taking any particular value for the arc S. Now Euler takes q is equal to pi by 2, taking q is equal to pi by 2, and s is equal to q, therefore y is equal to 1, and this makes p is equal to 1, that is this one. When y is equal to 1, p gives the result of 1 is equal to 1. So the number of, so the sum of the first power, of the first power of the terms of a series becomes becomes 1 is equal to 1 by q plus 1 by q plus minus 1 by thrice q plus minus 1 by thrice q plus 1 by 5q plus 1 by 5q plus minus 1 by 7q minus 1 by 7q, etc. Therefore, taking 2 by q common here gives a result of 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, etc. Okay, therefore 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus gives a result of q by 2 from here, q by 2. We have already taken q is equal to pi by 2, that is equal to pi by 4. This says therefore this says that 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus up to infinity gives a result of pi by 4. What is here? Now this fact was well known to Euler, and he attributes to Leibniz, and he also included this particular calculation. Now Euler turns to the sum of the square of his sequence. Now turning the sum of the sequence of his sum of the square of the sequence, and the sum of the square of the sequence, he gets 1 by q square plus 1 by q square plus 1 by 9 q square plus 1 by 9 q square plus 1 by 25 q square plus 1 by 25 q square plus, this gives a result 1 by q square common, 2 by q square common, 1 plus 1 by 9 plus 1 by 25 plus, okay. This sum equal to q. This sum equals to q. That is a sum of the square of the sequence. Okay. This gives the result of q. By definition, we mentioned the q is equal to 1 by y square. That is, gives the value of result q 1 by y square. By definition, q is equal to 1 by y square. Therefore, y is equal to 1. Therefore, q is also equal to 1. And we substitute the value here. Substituting the value, we get substituting the value, we get 1 plus 1 by 9 plus 1 by 25 plus 1 by 49 plus up to infinity to q square divided by 2. That is, q is equal to pi by 2 whole square divided by 2. That is pi square divided by 8. Therefore, 1 plus 1 by 9 plus 1 by 25 plus 1 by 49 plus is equal to pi square by 8. What it says, does the sum of the reciprocal of sum of the reciprocals of the odd square is pi square by 8. Okay, since every even square is a power of 4 times an odd square, and Euler knows that, since every even square is a power of 4 times an odd square, and Euler knows that. Therefore, 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 is equal to 1 plus 1 by 9 plus 1 by 25 plus 1 by 49 etc. into 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 is equal to pi square by 8 into 1 by 1 minus 1 by 4, that is pi square by 8 into 4 by 3, that is pi square by 6. Therefore does 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 up to infinity to pi square by 6. This is the first solution of Basel problem, and the Basel problem is solved. This problem is solved. First solution of Basel problem is solved, and this is the way how he does the second solution. For the second solution he taking y is equal to under root 3 by 2 in place of y is equal to 1, and it gives also the same result. So we are not discussing the second solution here, and the first solution and the second solution is kind of same operation, having same operation, so we are not discussing the second solution here. So this is the first solution of Basel problem put forward by Leonhard Euler in 1734. The sum of the square of its reciprocal of positive integers, that is 1 plus 1 by 4 plus 1 by 16 plus up to infinity, is exactly equal to pi square by 6. Thank you so much. Thank you for watching. Please like and comment and let us know, and stay tuned for the next series. If you didn't subscribe my channel, please subscribe it and press the bell icon for the notification so that you will get updated as I post a video. And thank you so much.